paper and fold it into halves to make a cone as shown here. Fix a funnel on a stand. Wet its side and keep the filter paper in the funnel. Pour muddy water through the filter paper. Clear water will be collected in the beaker below the funnel. The clear water obtained is called the filtrate. This method of purifying water is called filtration.
Distillation. Distillation is the process of heating a liquid to form its vapors and then condensing the vapors to form the liquid. It is used to separate two or more substances present in a liquid or for purification of water. The apparatus used for distillation is shown here. Let us see the demonstration. Take some salt water in a retort and heat it till the water gets converted to steam. The steam is collected in the beaker, which is connected to the retort as shown here. The steam condenses into drops of water and the salt is left behind in the retort.
Here we have a mixture of sand and iron, and to get this mixture unmixed, one thing we can use or take advantage of is the fact that iron is magnetic, and so I have here a magnet inside a plastic bag, and if I put that in there, we can very quickly pull out the iron out of the mixture, and then all we have to do is remove our magnet from the bag or invert our bag to get the iron fully separated. Now certainly at this point there is some sand still mixed in with the iron, but we could go through a refining process where we come in here and repeat the process, trying to each time get less and less sand caught up with our iron bits, and eventually we could get to the point where we had just iron in its own pile and our sand left on its own.
Study of acids, bases and salts. Introduction. Acids, bases and salts are three main classes of compounds. Acid. An acid is a compound which when dissolved in water yields hydronium ions as the only positive ions. An acid combines with a base to form salt and water only. Base. Substances that combine with acids to form salt and water are called bases. Alkalis are bases that dissociate in water to yield hydroxyl ions as the only negative ions. Salt. Salt is a compound which when dissociates in water yields positive ions other than a hydrogen ion and a negative ion other than a hydroxyl ion. Classification of acids. Acids can be classified in various ways depending on the factors shown here. Click on each of the factors. Strength of acid. Acids are classified as strong acid and weak acid. Concentration of the hydronium ions determines the strength of the acid. Greater the number, greater is the strength of the acid. Strong acid undergoes complete dissociation. For example, sulfuric acid, hydrochloric acid, nitric acid, etc. Weak acid undergoes partial dissociation. For example, acetic. Concentration of acid. Percentage of acid that is dissolved in water is its concentration. Acid which has relatively high percentage of acid is a concentrated acid. For example, concentrated HCl, concentrated H2SO4. Acid which has relatively low percentage of acid is a dilute acid. For example, dilute HCl and dilute H2SO4. Presence of oxygen. Acids can also be classified on the basis of presence or absence of oxygen. Oxyacids. Acids containing oxygen in their composition are known as oxyacids. For example, sulfuric acid, nitric acid, etc. Hydracids. Acids which do not contain oxygen in their composition are known as hydracids. For example, hydrochloric acid, hydrobromic acid, hydroiodic acid, etc. Basicity of acid. It is the number of replaceable hydrogen ions in an acid. In a monobasic acid, the number of replaceable hydrogen ions is 1. For example, HCl, HI, HNO3, etc. In a dibasic acid, the number of replaceable hydrogen ions is 2. It dissociates in 2 steps. For example, sulfuric acid. A tribasic acid has 3 replaceable hydrogen ions. It dissociates in 3 steps. Preparation of acids. The general methods of preparation of acids are direct combination or synthesis, acidic oxide in water, displacement of metal ions by less volatile acid, the action of dilute acid on salts, and the oxidation of nonmetals by concentrated nitric acid. Properties of acids. A few important physical and chemical properties of acids are summarized here. Classification of bases. Bases can be classified in various ways depending on the factors such as strength of base and acidity of base. Strength of base is the concentration of hydroxyl ions. A strong base undergoes complete dissociation. For example, KOH, NaOH and CaOH twice. A weak base undergoes partial dissociation. For example, NH4OH and MgOH twice. Acidity of base. Acidity of base is the number of replaceable hydroxyl ions. A monoacidic base has 1 replaceable hydroxyl ion. A diacidic base has 2 replaceable hydroxyl ions. And a triacidic base has 3 replaceable hydroxyl ions. Preparation of bases. The general methods of preparation of bases are direct combination with oxygen, decomposition of carbonates, decomposition of nitrates, double decomposition by dissolving basic oxides in water. Properties of bases. A few important physical and chemical properties can be seen on your screen. Amphoteric behavior. Basic hydroxide that can combine with an acid as well as an alkali to form salt and water displays amphoteric behavior. For example, zinc hydroxide. According to the modern concept, acid is a proton donor and a base is a proton acceptor. Neutralization is a reaction in which an acid combines with a base, neutralizing the positively charged hydrogen ion and the negatively charged hydroxyl ion, forming salt and water. The pH scale. pH is defined as the negative logarithm of the hydrogen ion concentration expressed in moles per liter. pH scale is a 14-point scale. It ranges from 0 to 14. Indicators. A chemical substance which indicates the end point of neutralization reaction by a sharp color change is known as an indicator. Universal indicator. It is a mixed indicator which shows whether the solution is acidic or basic and also shows the approximate pH values. Salts. Salts can be classified into many types, as you can see on your screen. General properties of salts. A few general properties of salts are shown here. Water of crystallization. It is the number of water molecules chemically combined in a definite molecular proportion with a salt. For example, CuSO4 5H2O. On heating, the hydrous crystal loses water molecules. Efflorescence. Certain hydrous crystals lose their water of crystallization and crumble into powder. For example, Na2SO4 10H2O. Hygroscopic property. Certain salts absorb water molecules from the atmosphere. For example, CaO, NaOH, etc. Deliquescence. Certain salts absorb moisture and dissolve in it. For example, anhydrous calcium chloride and magnesium chloride.
Acids taste sour, are corrosive to metals, change litmus red, and become less acidic when mixed with bases. Bases feel slippery, change litmus blue, and become less basic when mixed with acids. Acids and bases in the laboratory. Indicators are substances whose solutions change color due to changes in pH. These are called acid-base indicators. Indicators are used in laboratories to show whether a solution is acidic, alkaline, or neutral by their color changes. Some common indicators are litmus, methyl orange, phenolphthalein, and universal indicator. How do acids and bases react with metals? Acids react with metals, forming salt and hydrogen. Many acids react with reactive metals such as magnesium and zinc to form hydrogen gas and the salt of the metal. If a lighted match is held near hydrogen, it produces a pop sound. Bases do not react with metals because they are not proton donors. Reaction of carbonates and hydrogen carbonates with acids. Limestone, chalk, and marble are different forms of calcium carbonate. All metal carbonates and hydrogen carbonates react with acids to give a corresponding salt, water, and carbon oxide. Carbon dioxide turns lime water milky when bubbled through it. Reaction of acids with bases. Neutralization. How do acid and bases react with each other? Acids react with bases to form a salt and water. This process is called neutralization. Water is neither an acid nor a base. It is neutral. Other substances that are neutral are classified as salts. Reaction of metallic oxide with acids. Metallic oxides react with acids to give salts and water. This is similar to the reaction of a base with an acid. Metallic oxides are said to be basic oxides. Reaction of a non-metallic oxide with base. Oxides of non-metallic elements are acidic in nature. Reaction of non-metallic oxide with a base is similar to the reaction between a base and an acid. Non-metal oxides are called acid anhydrides. What do all acids and bases have in common? Some common properties of acids and bases are tabulated here. Please read on. Dissociation of an acid or a base in an aqueous solution. Acids are ionic compounds possessing a positive as well as a negative charge that break apart in water to form a hydrogen ion, H positive. Bases are ionic compounds that break apart to form a negatively charged hydroxide ion, OH negative, in water. How strong are acid or base solutions? Strong acids are acids that are completely or nearly 100% ionized in their solutions. Complete dissociation of an acid in an aqueous solution is shown here. The common acids that are almost 100% ionized are listed here. Strong bases are completely ionized in solution. For example, KOH dissolve in water in the reaction KOH is equal to K positive plus OH negative. The common bases that are almost 100% ionized are listed here. Importance of pH in everyday life. Plants and animals are pH sensitive. pH of the soil is important for healthy growth of plants. pH in our digestive system affects digestion. Tooth decay starts when the pH of the mouth is lower than 5.5. More about salts. A salt is any ionic compound composed of cations, positively charged ions, and anions, negative ions, so that the product is neutral, without a net charge. Salts that contain a hydroxide ion, OH negative, are basic salts, and salts that contain a hydrogen ion, H positive, are acid salts. Normal salts are those that are neither acid nor basic salts. When salts are dissolved in water, they are called electrolytes and are able to conduct electricity. Salts can be dehydrating to the human body if consumed in excess. Salts can appear to be clear and transparent, sodium chloride, opaque, and even metallic and lustrous. iron disulfide. Different salts can elicit all 5 basic tastes, that is, salty, sweet, sour, bitter, and savory. Family of salts. Salts having the same positive or negative radicals are said to belong to a family. For example, sodium chloride, NaCl, and sodium sulfate, Na2SO4, belong to the family of sodium salts. Similarly, NaCl and potassium chloride, KCl, belong to the family of chloride salts. pH of salts. A salt is formed when an acid and a base are mixed, and the acid releases H-positive ions, while the base releases OH-negative ions. This process is called hydrolysis. The pH of the salt depends on the strengths of the original acids and bases. Salts of a strong acid and a strong base are neutral with pH value of 7. On the other hand, salts of strong acid and weak base are acidic with pH value less than 7, and those of a strong base and weak acid are basic in nature with pH value more than 7. Chemicals from common salt. Common salt is a raw material for various materials of daily use, such as sodium hydroxide, baking soda, washing soda, bleaching soda, bleaching powder, and many more. How one substance is used for making